It's been a while since we released our video on your first home server, and now it's time to talk about what to install on it. Now listen, there's no shortage out there of different systems you can run on a home server, from virtualization to hyperconverged to straight Linux containers to, dare I say, even Windows, and there's no right or wrong answer. It all depends on what you want to get out of your home server. So we're going to get this party started off first with TrueNAS Scale, so let's get to it. Welcome back, Homelabbers and self-hosters. Rich here. As promised, we're back with the next installment of your first home server. If you missed the first video, check it out because it goes over the what, whys, and hows of choosing the right piece of hardware for you. Now, let's get some software installed. And the first platform we're going to go through is TrueNAS Scale. I know many of you watching this have likely already heard of either TrueNAS Core or TrueNAS Scale, but let's get an overview first. TrueNAS Scale is an open-source, hyper-converged storage platform running on top of Debian Linux. Don't let the technobabble scare you away. Scale is jam-packed full of all the features you'd want for a home server, all running on a single platform. Let's dig in further. Scale, first and foremost, is a storage platform built on OpenCFS, which is designed to protect your data and keep it safe. Scale supports SMB network shares, which is the standard network share for Windows, NFS network shares for Unix and Linux systems, as well as complex storage services like iSCSI, which are typically used for storage backends on virtual hosts. Next, Scale has full container support built into it. This means you can quickly start up and run containers on your home server without the hassles of manually pulling down apps and packages or dealing with the complexities of compatibility. You want to run Plex? Installation is just a few clicks away. Third, Scale allows you to do simple virtualization. Scale allows you to create and run virtual machines, giving you a one-stop shop for all the things you'd want your home server to do. And the best part is that TrueNAS Scale is completely free and has a massive community of users behind it. The company that makes TrueNAS Scale, IX Systems, is also a genuinely great company that cares about its products and its users, something that's rare in the industry. I'm going to walk you through downloading Scale, writing it to a bootable USB stick, installing it on the computer from the first video, walking through a basic setup, and set up a few containers to give you an idea of just how extensible and easy it is to use. Our first stop is to get the newest install ISO available from TrueNAS.com for our host. To do this, we'll open a web browser and head over to TrueNAS.com. At the top right, we'll click the Get TrueNAS link and select Download TrueNAS Scale. You can sign up for the TrueNAS newsletter, which is a great resource for all things TrueNAS, or you can click the No Thank You link at the bottom. Now we'll click the button to download the current stable release of Scale and download the ISO. Now let's build our bootable USB stick using Rufus. Rufus is super easy to use. Go grab a copy from rufus.ie and launch it. Once you've got it up and running, it should look like this. We've already inserted a 16 gig USB stick. You can get by with a 4 gig stick at a minimum. Now we'll click Select. Navigate to the ISO we downloaded from TrueNAS.com, select it, and click Open. All that's left to do here is click Start to kick off the process. This ISO is a hybrid ISO, so we'll need to tell Rufus how to write the data to the USB stick. We'll leave it set to the default Write in ISO image mode and click OK. Final stop. This is a destructive process that will wipe the USB stick and create our Scale install stick. If you've got data you want to keep on this USB stick, copy it off or say goodbye to it. Let's click OK and get this party started. Building the stick can take a bit depending on your USB stick and your PC, so let it finish. And done. Alright, we're ready to kick off our Scale install. Let's quickly talk about our host here and the requirements of TrueNAS Scale. Our host has 4 drives in it currently, 2 4TB Western Digital Red Pro hard disks and 2 500GB Western Digital Blue NVMe SSDs. This disk configuration will give us a few choices when it comes to how we provision the storage in TrueNAS, and we'll get to that after the install. The host also has 32 gigs of RAM, which is the perfect amount for TrueNAS in this hardware configuration. And as an important side note here, TrueNAS uses OpenZFS, and ZFS relies heavily on the system's RAM for caching. It's because of this that it's highly recommended that you use ECC RAM. ECC stands for error checking and correcting. It's basically RAM that can detect when there's something not right in the data in the RAM and fix it. And our host has ECC memory, so we're in a good spot for that. Can you run TrueNAS without ECC? Yes, you can, but it's slightly more risky to do so, and depending on how important your data is to you, you might want to reconsider it. One more thing before we kick off this install, TrueNAS Scale needs a disk to be installed on, and I'd like to keep all 4 disks up front usable for storage, so I'll be installing another NVMe in this host on one of these simple PCI Express to NVMe adapter cards. That way I won't have to sacrifice one of my SSDs up front for the OS. And with that, let's get to the install. Once you've booted off your USB stick, you'll be greeted with the Grub bootloader for the Scale install. You can hit enter to move on or wait 10 seconds to continue. Alright, here we are at the TrueNAS console setup screen. Obviously, we're here to install Scale, so we'll hit enter to continue. Now we're shown a list of all the detected storage devices in our host. We have 3 500 gig NVMe's, 2 in the front in the flex bays, and 1 I installed just for Scale to live on, and 2 4TB mechanical hard disks as well. We're going to use the spacebar to select the first NVMe as our install target and hit enter to continue. This is just a warning to let you know the disk we selected will only be used for Scale and completely wiped of data. We'll hit enter to continue. Alright, the Web UI authentication method screen is all about choosing how you log into the Web UI of Scale. In previous generations of Scale and Core, the root user was the default and there wasn't even a choice. In recent versions of Scale, TrueNAS has been moving away from using the root user and instead recommending creating an admin user for use when logging into the Web UI. This change was done for security reasons and to discourage the use of root as a default login. I recommend you go with the admin user because that's the direction Scale is moving, so we'll leave it set as is and hit enter. Alright, it's password setting time. Set a password that you can remember but is sufficiently secure. None of this password 123 stuff, do it twice and hit enter. Now we're asked if we want to create a swap partition for our install disk. I recommend you do this if you're offered the option. For people with small install disks, you won't be asked as it's not a requirement, but will benefit the system performance-wise if you can. Hit enter to continue. And now the Scale install is off and running. Depending on your hardware, this can take a bit to finish, so, go grab a drink or something. Boom, just like that, Scale is installed. Hit enter to finish up. Back on the console setup screen, let's navigate down to reboot and press enter. Remember to pull your USB install stick after hitting enter. Alright, let's get our first boot of Scale going. We'll see the grub bootloader appear just for a second and then it'll start booting Scale. The first boot of Scale takes the longest because there are a bunch of post-install processes that need to be completed, including creating certs, loading the middleware modules, and so on. Be patient and let the process complete. And here we are, the console setup screen. This is effectively all you'll see in the monitor output on your host from now on. You'll spend almost all of your time interacting with the web interface of TrueNAS Scale from the comfort of your web browser. Our host only has a single 1 gig NIC in it, and by default, Scale is using that and grabbed an IP address via DHCP, and we see that IP address here. It's now time to open a web browser and log into Scale. Alright, throw that IP address listed on your console setup screen into the address bar of your browser of choice. If all goes well, you should be greeted with this, the login page for TrueNAS Scale. If you remember during setup, we chose to use the username admin as our username, so we'll throw that into the username field. And then we'll enter the password we set up during the setup process as well. And then we'll click Login to get this party started. Welcome to the dashboard of TrueNAS Scale. On the left side of the page is the navigation menu where you'll make configuration changes, set up storage pools and shares, and deploy containers and VMs. Directly in front are 6 at-a-glance cards that provide you with information about your host, including version information, help, CPU utilization, memory utilization, storage pool utilization, and network utilization. You'll notice that the storage card is empty because we haven't created any storage pools on our host yet. Let's do that now. Our first step here is to create storage pools to hold our data. In TrueNAS, a pool is a collection of storage devices that provide a level of redundancy in case one of those disks fail. Our host has 4 disks, 2 500GB NVMe SSDs, and 2 4TB mechanical hard disks. It's not advised to mix disk types together, so we'll be creating 2 storage pools with 2 drives each. This is traditionally called a RAID 1 or a mirror and provides redundancy if one of the drives in the mirror set fails. Let's build out our 2 storage pools now. We're headed over on the left to storage in the menu. As you can see, we don't have any pools configured on this fresh install of Scale, so we'll click the Create Pool button in the middle. We'll build out our NVMe storage pool first, and we'll head over to the Name field and name this pool NVMe. In the Available Disks list below, we see all the drives available on our host, and since we're building out the NVMe pool first, we'll head down and select both NVMe disks named NVMe 1N1 and NVMe 2N1. Now we'll click the right arrow in the middle and add those 2 disks to our data VDEV. Because there are 2 disks added, Scale assumes that we want these 2 disks in a mirror configuration, so there's no reason to change that setting. A VDEV or virtual device is a collection of disks assigned to a pool that have a specific function. A data VDEV holds your data, and you can have multiple data VDEVs in a single pool. We made a whole video on data VDEV layouts and what's the best configuration. Check it out if you're interested. Last thing to do here is just click Create at the bottom, acknowledge the warning on disk erasure, and get this pool created. After the pool creation is complete, we now see info cards that provide information about the health, usage, and configuration of the pool we just built. These at-a-glance cards are there to help you keep an eye on your pool's health and usage and allow you to modify the pool easily if needed. Let's build the hard disk pool now. In the top right corner, we'll click Create Pool so we can kick off round 2. Back to the name field, and we'll enter HDD, then in the table below, select the two mechanical hard disks we have in our system, labeled SDA and SDB. Incidentally, SDC listed there is actually the SD card slot on our system, which is why it shows 0 bytes. Once again, we'll click the right arrow in the middle to add the two hard disks to the Data VDEV table, head down to the Create button below, and then confirm the erasure and complete the pool creation. And back on the storage dashboard, we see both pools listed with their respective details. Awesome! All of our pools are built. Now that we have our pools, we need to create a dataset to access that free space. Datasets are a means of organizing your data and keeping it separated from other data on the same pool. For example, let's say you want to run Plex and manage your media, but you don't want that data being mixed in with your other data. Creating separate datasets for different uses can help you control access to the information easier and organize your information in logical ways that make sense to you. Let's build some now. Back to the dashboard again. We'll head over to the left and click on Datasets to get started. On the right, we see the two pools we just created a bit ago, HDDs and NVMe. We're going to build an example dataset in each of the pools to show you how to do it, starting with the HDDs pool. We'll swing over to the top right and click Add Dataset. Our dataset needs a name, so we'll enter Dataset1 as an example here. I recommend you name your dataset something that makes sense for its use case. There are quite a few different options you can play with here to customize your dataset's functionality. Making changes to these settings can have a variety of different effects on your dataset, but thankfully the defaults are all we need here. We'll scroll down and hit Save below, and we're done. Now we see our newly minted Dataset1 listed under the HDDs pool. Perfect, let's build a second dataset on our NVMe pool. We'll click on the NVMe pool on the left, and then swing back over to Add Dataset on the right. Once again, we'll give our dataset a name, and then head down to click Save at the bottom. Now we see our new dataset listed under our NVMe pool. Super easy. Okay, we've done all the groundwork we need to start adding services to our home server. Our next stop is to show you how you can easily spin up containers in TrueNAS SCALE and start reaping the benefits of your home server. If you're wondering what a container is, imagine having a magical box or container that holds anything that you want, like an app or a program. This box is special because it has everything the app needs to run smoothly. The app itself, its settings, and even the tools it relies on. It's like a mini self-sufficient world for the app. Now, this magical box can be easily transported and placed on different computers. It doesn't matter if the computer is a powerful server or a regular laptop, the box will work the same everywhere. This makes deploying them super easy and user-friendly for quickly getting the apps you want up and running fast. Let's walk through setting up a container on TrueNAS SCALE. Alright, in TrueNAS SCALE, containers are managed through the Apps section. We'll swing over to Apps on the left. This is the first time we've opened apps on Scale, and we need to choose a storage pool to hold our containers. We're going to use the NVMe pool to hold our apps, so we'll click the drop-down and select the NVMe pool, and then click Choose. Scale will take a moment to build out the apps dataset and prepare the system to start running containers. Give it a moment to get finished. And done. Scale has a large app catalog built in to make selecting and installing the apps you want quick and easy, and their catalog is growing fast. As you can see, the list is quite large at the time we created this video, and you'll find almost all of your favorites ready to install like Plex, Pi-hole, Nextcloud, and so many more. To show you how easy it is to spin up a container, we'll install Pi-hole. First, we'll locate Pi-hole in the list and click the Install button. On the slide out on the right, we're provided with all the possible settings and configurations for our Pi-hole container. Keep in mind that for each container you're deploying, you're likely to have general and unique configs specific to the app itself, so take some time and read up on the app you want to deploy. For Pi-hole, the only configuration we need to make here is to provide a password for the default admin account. So we'll swing over to the admin password field and put in a password. Now we'll scroll down to the bottom and click Save to deploy our Pi-hole container. To check on the status of our installing container and manage existing containers, we'll use the Installed Applications tab at the top. Here we see our Pi-hole container is still deploying. Deployments can be fast or take a while depending on the app you're installing. Alright, now on the top right of our Pi-hole card, we see a status of active, meaning our container is up and running and we can start using it. We'll swing over to the Web Portal button to connect to our Pi-hole's web interface. Boom, Pi-hole is up and running. Let's log into it using the password we set with the built-in app. It looks like all is well and Pi-hole is ready to start serving up some sweet ad-free DNS. Awesome! Containers are a really great way to deploy all of the home server services you'd want to run, and there are a ton of how-to videos on the TrueNAS channel, as well as from other really great YouTubers out there. I highly recommend you check them out to get your container deployments going quick and easy. And that, friends, will do it for this installment of your first home server. If you liked it, give us a thumbs up and a sub, and if you have a beef with anything I've said, get down in those comments and let me know. Special thank you to our YouTube members for supporting the channel. If you'd like to help support the content we make here, consider becoming a member or buy some swag. It all helps us create more content. And now that you finished watching this video, how about checking out our Homelab and virtualization playlist over here? If you're looking to get into home labbing, self-hosting, or virtualization, we can help.